Hi Geometry, this is Unit 6, Lesson 2's notes on page 657 of our workbook. So in our Unit 6 folder, there is a PDF of coordinate transformation rules that you're supposed to write on page 656. So make sure you do that because the different rules I'm going to be using during this lesson come from that chart that you're going to copy into your workbook. So let's begin. It says to translate A, it's a translation by this directed line segment. Another way to write a translation is to say what's happening to our coordinates. So if we start at 0, 0 and we're going to 0, 2, it means my x coordinate, nothing's going to happen. But my y coordinate, I'm going to add 2 to it. If you think of starting at 0, 0 and going up to 0, 2, I'm just adding 2 to my y coordinate to do that translation. So to do that to A, to get A prime, that means that my A, which is 3, 2, would go to A prime, and I'm going to leave my x the same and add 2 to my y. So my A prime would be at 3, 4 on my graph. So then let's take a look at translating A by the directed line segment 0, 0 to negative 4, 0. So in this case, I'm going to take 4 away from my x coordinate, but I'm not going to be changing what my y coordinate is at all. So in this problem, to do this translation, I would start at my 3, 2. So my A is 3, 2, and if I'm going to do, we'll call this guy A double prime. This is my A prime. This will be A double prime on my graph, A triple prime, and A quadruple prime. So I'm going to take 4 away from my x coordinate, which actually would put me at negative 1, and not change my y coordinate at all. So this then would take my A to negative 1, 2. I would shift this way, just 4 to the left, and this would be my A double prime. So now it asks me to reflect A across the x-axis. From our table, I know that this means that my coordinate that I have when I reflect it goes to x negative y. So for example, if I thought of my coordinate being 3, 2, then if I want to reflect over the x-axis, my new coordinate, my x coordinate stays the same, but my y coordinate becomes the opposite, in this case, a negative 2. So I would go to 3, negative 2, and this is where A triple prime is. You might say, well, I already know that simply by the way I count. I agree. It's just, this is just a coordinate rule, and if you want to use it, great. And if you do it some other way, that's also great. So now a 180 rotation clockwise, which it doesn't really matter, clockwise or counterclockwise, 180 degrees is the same thing both directions. But around the origin is really important. I do have a rule for that. My xy goes to negative x, negative y. Keep in mind that that might mean that negative numbers are becoming positive. When I say negative x, I just mean the opposite sign. A negative negative would turn it back into a positive. But in my problem, since my A is 2 positive coordinates, when I make them both negative, it becomes negative 3, negative 2. So when I rotate 180 degrees around the origin, I come over here to negative 3, negative 2 for my A quadruple prime. So let's take a look at the next activity. So on this activity, it asks us to plot these points under this transformation. So my A prime would be, I'm going to add 12 to my x, which would be 2, and I'm going to subtract 2 from my y, which would be 3. So it looks like my A prime would be this 2, 3. So why don't you pause this video for a moment, find your B prime and C prime, come back to check to make sure that you have the correct coordinates. So I hope you got 8, 7 for B prime and 10, 4 for C prime. So next, if you look at the next page, it asks us to graph ABC and also A prime, B prime, C prime. So why don't you graph those? Pause this video, graph those, and then come back and check your answers. So I hope you got 2, 3, 8, 7, and 10, 4 for your image. And you'll see the original graphed in blue above and the image graphed in red. And when you look at this, this looks like it was a translation. I slid my triangle across the grid. So at the top of the next page, it asks what type of transformation this is, and this is a translation. We can also write this as a movement from for example, from 0, 0 to 12, negative 2. So whether it's written in coordinate form or it's given to you as coordinates, we're moving 12 in the x direction and we're moving down 2 in the y direction. So let's take a look at number 3 here. This chart, it wants us to fill in with our new coordinates. Each one of these coordinates, we're going to multiply our x coordinate by 2, for example, negative 2, and our y coordinate by 2, 6. So take a moment and find the remaining 3 coordinates, and then sketch the original, that would be the left column, and the image, that would be our new right column, and what type of transformation is xy to 2x, 2y. So do those items, pause the video, do those items, and then come back and see if you have the correct answer. Welcome back. After you graphed the 2 rectangles on the graph and looked at them, hopefully you noticed that this was a dilation with scale factor of 2. It's important that the 2 times x and 2 times y is the same number so that both the x and the y directions are changing by the same amount. So let's take a look at this activity. It says here are some transformation rules. Apply each rule to the quadrilateral ABCD up above in the picture and graph the resulting image. Then describe the transformation. So let's do A together. So in A, I want to take my XY coordinate of my ABCD and I want to multiply the x by 2 and keep the y coordinate the same. So there's 4 coordinates up here that are part of ABCD. I have A, and that is 3, negative 1. B is 5, negative 2. C up here is 3, negative 6. And D is 2, negative 2. So if I multiply my x coordinate by 2, that's 2 times 3, I'd get a 6. And I'm going to keep y the same. So my new coordinate would be 6, negative 1. And if I multiply the 5 by 2, I get 10. And I'm going to keep the y the same, so it would be negative 2. And if I multiply the 3 by 2, I get 6. And my y then would be negative 6. And finally, if I multiply the 2 by 2, I get 4, and my y is going to stay negative 2. So this is the 4 coordinates of my transformation that I'm going to label Q. So let's go graph this. 6, negative 1, and 10, negative 2, and 6, negative 6. So 6, negative 6, and 4, negative 2. So I'm going to graph this here, and that's my Q. And then it says to describe this transformation. Well, this transformation is not a dilation because I didn't change both the x and the y coordinate by the same scale factor. In other words, I don't have a 2y here. I only have a 2x. And so this is a transformation. Specifically, we would call it a horizontal stretch because I'm changing my x coordinates. My x coordinates are growing by a scale factor of 2, but I'm not changing my y coordinates at all. So it would not be a dilation is the important takeaway of that one. So I'm going to have you pause the video and do B and C on your own. Please note that when you create your tables for R, that's B, you have your same x, y coordinates, A, B, C, D. So that has not changed. It's the same 3, negative 1, and 5, negative 2, and C and D as well. And this time, you're going to change it to x, negative y, or the opposite of y. Remember, a negative negative is a positive. And you're going to graph that. And then finally you'll do S. So let me make a table for my S. I have my X, Y, and then S is asking me to flip-flop my X and my Y. After I flip-flop it, I'm going to make the second term negative, and I'm going to do it to the same A, B, C, D that I've been doing it to. So that would be my 3, -1, and my 5, -2, and my 3, -6, and my 2, -2 of A, B, C, D. So why don't you fill in the tables for R and S, and then graph those up above and come back to the video and see how you did. So you could pause the video at this time and check that your coordinates in your tables are correct, check that your diagrams up on your chart are correct, and notably, C is a rotation of 90 degrees clockwise around the origin. You could also say it's 270 degrees counterclockwise if you want to go the other direction, but that's been rotated into that third quadrant, the shape. Thank you very much.